Hi everybody, I'm Kara Naji, a student at SUNY Bali. Today I'm going to explain three problems in physics. The first one is going to be from chapter 4, problem 35, which has like supposed to be in this figure, which has two masses, two blocks. And is suspended by a cord. They need us to determine the tension in this cord after the masses are released and before one hits the ground. So the first thing we are going to do is draw a free body diagram, which is here. So we are going to have, so let's just say this is mass 1, which is 3.2 kilogram, and that one 1.2 kilogram, and then we are going to have a gravity, so m1g, and here m2g, and also here's we are going to have, since it's the cord, we are going to have tension force, and here also we are going to have the same tension force for both of them. And here we have center force. So if you noticed here, we have the two blocks, we only have like the two masses. So we are going to play a little bit with the equations. So here, for the first tension, if you notice that the same tension force is applied to each masses, so we are going to only to have one force tension. That's why we need to play a little bit with the equations to find the correct tension with two masses on it. So from Newton's second law, we have the sum force equal ma. Since we have two masses, we are going to have two equations. For each equation there is one mass. So here, tension force minus m1 gravity equal to mass 1a1. This is the first one, and the second one is going to be the same thing but different mass. Tension force minus m2g minus m2a2. If you see here, since the masses are joined together by the cord, their acceleration will have the same magnitude but opposite directions. So we are going to have a1 equal negative a2. It's the same magnitude but different direction. So we are going to have this. We are going to substitute the a1 in equation number 1, and also here it's 2, equation number 2. So here let's just substitute it and solve for a. m1g equal m1 negative a2. I'm not going to skip any steps, so you're not going to get any confused. Tension force minus m1g equal to negative m1 a2. So here, since we are going to solve for acceleration 2, we need like, I don't like negative, so I'm going to get out from it. You can get out from the negative by multiply negative 1 by negative 1, or just switch the each part. For example, I'm going to take this part to the left side, and I'm going to take that one to the right side. So this is negative, so it's going to be positive in the left side, equal to m2g minus tension force. And here, just solve for a. It's going to be equal to m2g minus tension force over m1. So here, since we have the value like we like solve for acceleration 2, we are going to substitute it in the second equation. Take the second equation, tension force minus m2g equal m2, acceleration 2 is going to be this m2g minus ft over m1. Multiply, just simple as possible as you can, and then we are going to solve for tension force. Equal to, since we are going to multiply m2 distributed in these two parts, we are going to have m1 m2g minus m2 tension force over m1. Cross and multiply, and then we are going to get m1 force tension force minus m2g, I'm sorry for that, equal to m1 m2g minus m2 tension force. Here we are going to multiply, so we are going to get m1 tension force minus m1 m2g equal to m1 m2g minus m2 tension force. Now we are going to take the tension force in one side and take the other variables to the other side. Since we are going to solve for tension force, we are going to take this, it's already here. I'm going to move this part, the tension force, to the other side, which is going to be positive m2 tension force equal to m1 m2g, and I'm going to take this part to the other side. Here we are going to simplify it. I'm going to factor in the left side, and I'm going to add in the right side. I'm going to factor tension force, and I'm going to left with m1 plus m2 equal to, add these together to m1 m2g, and then I'm going to divide it to solve for tension, to m1 m2g over m1 plus m2. So that's it. Now we are going to plug numbers and find tension force. Equal to the first for mass is 3.2 kilogram, and the second one 1.2 kilogram, and the gravity 9.8 meter per second square. And here the mass 1 and mass 2, and then just find it. And the final answer is 34, and the unit of force is Newton. So this is the first problem. So and the second one is going to be from chapter 6, problem 14. We are going to have it's about like a jet has a mass of 17,000 kilogram, and it takes off from an aircraft carrier, and they only need us, and there is like a constant force for the gas, which is 130 kilonewton, and they need us to find the work. They need us to find the work done by gases and work done by Kate Blood. So it's easy to find the work done by the gases, since we have the force constant. So it's it's constant force, so we only need to just calculate it from the rule or the equation. It says work equal force times this displacement, and the displacement, as you see here in the diagram B, it's the same displacement in the gases and the same displacement in the cat plate. Yes, cat plate. So first thing, we are going to find the work done by gases. So the first thing we are going to find work done by gases. So the equation is going to be W work equal force displacements. Here we have the force, which is constant, 130. Since it's kilonewton, we are going to convert it to newton. So multiply by 10 to the 10, and the displacement 85. The final answer is going to be 1105,000 Newton times meter, and we are going to take the average of it, round it. It will be 1.1 Newton times meter. Just we need like two significant figures. For the second one, we have two methods. I'm going to use the second one because it's easier, and you will see how you get there. So the second one, work done by catlets. So for the second one, we need force average. So the equation is going to be work equal force average multiply by displacements. The thing is, we need the force average, because here, if you noticed, the force, it was 100 Newton and the kilonewton, and then it decreases to 65. So we don't know which one. So we need the average of the force, and then easy, we have the displacement, and then just multiply it. So let's say here first one, to take the first force average, we are going to have force 2 minus force 1 over 2. Force 2 is 100 minus 65 over 2, which is going to give us 5.82. 5 times 10 to the 5 Newton. So I just convert it. Here, the work, the first average is that one, 5.825 times 10 to the 5, and 85 meter. Here the work is 5.0 10 to the 7 joule. And this is the final answer for this problem. So here, the last problem is going to be, we're going to have it about from chapter 8 and problem 46. So this is the diagram. So it says here, two blocks are connected by a light string passing over a body of radius 0.15 meter, and moment of inertia. The blocks move toward the right with this acceleration. And first of all, in this problem, if you read it, you're not going to get anything. Like, it's a little bit confusing. So let's just analyze the problem. So the problem has two blocks on the inclined surface, and they are attached by an elastic string. So they should have the same acceleration, and here it says the acceleration for both of them 1 meter per second square. And the police mass is not ignored. So we know that because the problem mentioned that there is a moment of inertia, and we are going to find out. So what are the given information? This is the first thing that we need to think about when we solve a big problem like this. So they give us it's the mass 1, which is, we're not going to say mass 1, let's say mass A. So as it's mentioned in the problem, mass A, it's 8 kilogram. Mass B, 10 kilogram. Acceleration for both of them, 1 meter per second square. And the first angle, which is angle A, is 32. And the second angle is 61. And the radius is 0.15 meter. So you're not going to see all this information from the problem. Actually, it's from the diagram, but when I just printed the numbers not showing in, so I'm going to write it right now. So this is the given information, and what's needed information, what's they ask about. They ask to find 4 things. The first thing, they ask to draw free body diagram. And the second thing, they want us to find tension force for A and tension force for B. And the third thing, they need the net torque. And the last thing, they want us to determine moment of inertia. So we are going to start with the first part, which is free body diagram, which is easy to draw if we know how to draw. So the first thing, we here, let me label things as it's in the graph, the figure. So here's 61 degree, here 32 degree. Here the masses, we already have them here, and also the acceleration. That's it, and they only have here like this. Tension force B. Here tension force A. That's it. That's the whole thing they have. So I'm going to draw the free body diagram. So we are going to have, let's see, here. Okay, so this is the center of it. So we are going to have gravity, which is MB, gravity, okay? And here, as you know, tension, force, B, and here, normal force, which is going to NB equal to MB cosine 61. let me tell you something. Here I'm going to, since I get confused when I'm going to write cosine, when it's going to be sine, so let's divide the boxes. So let's do where it's going to be x-axis and y-axis. So here, this one x-axis and that one y-axis. In the x-axis, it's going to be cosine. So in this part, it will be cosine. Here, it's going to be sine. And let's do the same thing for the second block. Here we are going to have totally opposite. Here the x-axis and here the y-axis. So it will be now clear for you so that you're not going to get confused at all. And here for here also we have, since I don't have any room here, I'm going to make it longer here. So here we are going to have MB. I don't have that much room, but it's okay. You can just see it. MBG sine 61. We are going to have two sine and two cosine since we have two angles. So this is for just the first block. The second block, we have a big room for that one, and that's good. So for the second block, we have here the x. Here we are going to have tension first. Tension first. For A, we need to determine if it's A or B. And here, MA, which is the gravity, G. And here, since we said this is the x-axis, we are going to have MA gravity sine 32 degree. And here we are going to have the normal force for A. It's equal to MA G cosine 32. We're not going to use all of them, but just to simplify it. So this is the first thing we did. So this is the free body diagram, this is number A, which is asked about. Draw free body diagram. The second thing is to determine the tension force for A and B. So now we are going to find the tension force. We can just find it here. Let's write B, the tension force for both of them. So by Newton's second law, we can figure out that tension force for A minus MA G sine 32 equal to MA A. So here from the second law, so if you're on Newton's second law, which is some forces equal MA, and we have two masses, so we are going to have two equations. So this is the first one, and the second one is going to be the mass B. We are going to have the same thing except different degree and different masses. Minus MB G sine 61 degree. If you notice that we took them from here, this is the first equation that we used, and that one, since here the y-axis, and we also took this part. Of course, we didn't take this part because it's in the x-axis. Since we are going to find tension force, we only need the y-axis, so we don't need to take anything from the x-axis. So we took the y. So let's write here the sum forces for y. So we're not going any confuse. And here we took that one and the force tension, just y-axis. That's what I did. So this is the first equation and that one the second one. So let's just solve. So let's like plug numbers and find for each one. So this is the first equation. This is the second. Since it says find the tension force for A and B. So first we are going to find it for A and then we are going to find it for B. The first thing, let's find it for A. So simplify first. Let's simplify the problem and solve for tension. Move this whole side to the other side, which is going to give us MA A plus MAG sine 32 degree. So the mass is known. So the mass A is 8 gram. The acceleration 1 plus mass A 8, gravity 9.8, sine 32 degree. If you plug it in the calculator, you are going to get 9 point, no, I mean, if you are going to plug it, you are going to get, I'm sorry for that. Okay, you are going to get 9.5 Newton. So this is the first tension force, and the second one we are going to find it. I don't think I'm going to have a room here, so I'll just add it another paper. So here, the second part of this, I'm going, or you know, let's do it here. Okay. So the second part, tension force B equal to, simplify it as the first one we did, MBA plus MBG sine 61 degree. Okay, so just block numbers. That's the whole thing we are going to do here. The mass B is 10 kilogram, acceleration 1 plus MB 10 kilogram, 9.8 sine 61. It will give us 75.7 Newton. So since we find the first thing, we did the body diagram, free body diagram, and the second one we found the tension force A and the tension force B. Now we are going to find the net torque, and then we are going to find the inertia. So the network we are going to find, we know that the net torque could be calculated using the following equation. I'm going to write it down. So I'm going to use another sheet because I don't have that much of room. So the third thing we are going to find the network. So the equation we are going to use to find the network is the net torque. I'm sorry. The net torque is torque equal force time displacement. As you know, also it's equal to inertia times alpha. So here, if the force equal tension force B minus tension force A, and D equal to R, then the angle between them is going to be 90, and the sine of 90, 1. So let's write it, and you are going to understand everything. So the first, we are going to take because we already find tension force A and tension force B, we are going to subtract them, and the R is going to be the D. The radius is going to be the D. So F, we are going to find it from tension force B minus tension force A, and the D is going to equal to radius. So it's easy to find it from here. And the torque equation is going to be like this. It should be force sine theta R. Okay? Since the sine is 90, so the sine 90 is 1, so we don't have even to include it. Just we are going to finish the work. That's the whole point. If the force is going to be, we already found it here, the force B, which is 75.7 minus 49.5. So this is tension force B minus tension force A. It's multiplied by the radians, which is 0.15, and the torque is going to give us 3.93. And the unit, don't forget, Newton meter. So this is the torque. And now the last thing we need to do to find is the inertia. So using the net torque in this step, we can find the inertia. As you know, the torque. So let's just write it down. So D D is going to have. Okay, so D torque equal to inertia times alpha. I don't know how to write alpha. Okay, so since we need to find the inertia, we are going to solve for first we need to find alpha, and then we are going to find the torque. Inertia, because we already have the torque, just we need to find the alpha and then the inertia. So since alpha is we can find a calculator from this equation. Acceleration equal to radius, which is r alpha. We have the radius, we have the we have the acceleration, and we have the radius, so we easily can find the alpha. So it's going to give us, let's solve for alpha. Acceleration over r. So here we already have alpha. We just need to plug the numbers, and we can do it in two ways. The first one, we can just find the alpha and then find the inertia, or we can find both of them at the same time. So we just substitute it here. The inertia is going to be equal to torque over alpha. Here, let's take it and take inertia equal to torque over alpha. The torque is 3.93 Newton times meter over. The alpha is here, so A is 1 meter per second square over r radius 0.15 meter equal to. We need to be careful with the units and with the numbers when we plug it in our calculator. So the final answer is going to be 0.59 kilogram times meter square. So this is the final answer for the problem 46 for the inertia.